We have this mechanical system that you see on the screen right now, and the objective here is to obtain the bond graph model and also obtain the transfer function as is specified in there. So to do that, we need to get, we have the system in here. First, we need to build the bond graph model, and then we need to specify the output. So in here, let's just say, I'm going to say objective. My objective is do the bond graph model, and then I am going to find, second objective is find the transfer function, and this transfer function is theta 2 is the output in here. So theta 2 is as it relates to the input torque, which is T of S in here. This is what we want. To achieve this, I am going to draw the bond graph model right on the system itself so as to relate one-to-one to the physical system. So I'm going to write one junction for omega 1, which is would be, maybe we can write it this terms, theta 1 dot like that. And I'm going to do another one junction here, which is going to be theta 2 dot. And then I will also draw a one junction here for theta of the wall equals to 0. And I will do the same thing on the right hand side over here, which I will say theta of the wall also equals to 0 here. Yeah? So I start here. Now step number 2 is to attach the elements that actually experience this angular velocities. So in here, obviously, this one has a I element in here with value j sub 1, right? And in here it has also an I element with value j sub 2. Yeah? Now we recognize also the other elements. You know, this one in here is the source element with velocity 0, and so is this one. Let's just write that in there. So this is an SF element in here that has theta of the wall equals to 0, and this is my reference point. So this will be SF with theta of the wall also equals to 0. Wow, very good. Now you see in between these two, we have this spring. So the springs is the relative motion, in this case rotational motion, between the theta 1 dot and theta 2 dot. So we have a C element in between with value 1 over k. Okay, but then this torsional k, right? That's what it is. And you see in here, this element sees the difference between this and the wall. So this also, we use a 0 junction in here, and we connect this with this, and of course in here that is going to be theta 1 dot minus theta of the wall, theta dot of the wall. That's what I meant to say here. On the is actually the angular velocity here. Okay, and attached to that, you see you have this R element with value d sub 1. And on the other side, if you come on the other side right here, you see also another one. And this one sees the difference between that and this, which would be, and this is a one junction, that means theta sub 2 dot minus theta dot of the wall. And attached to this, we have the R element right there with value d sub 2. Interestingly. So you can see by writing the bond graph model on the system, normally I don't do this to begin with, but since you have a little practice now, it is time that we move on and we do it on a one-to-one correspondence of the system. Okay? So right now, let's keep in mind our objective. Our objective is theta sub 2 dot, and so in relationship to the input, which is the torque. And in here you see, how do we represent that? In here we have that input in here, which is source of effort, which is this torque with value t. Okay, I believe we are ready to enter this into the CAMG software. And let's just go and do that. And in here we're going to go and say, we're going to try here. This is an example I was trying. We want to go and do that and enter this in here. So one thing that we know in here is that we can enter this in any order that we want. So I think that what we need to do is perhaps have it on the side so that I can take a peek as I am drawing in here. Let's just, this is a good picture in here. And that was the source of flow. So it's not allowing me. I need to move this to the right some more so that we have, do you see what I mean? I want to have it visual here. Okay, so why don't we start in here? Like I said, I can start anywhere that I want, and the computer is gonna, at this point we follow just the way it's on paper. Before we did follow an order on how to generate the bond graph model, but that's not the case when you are actually entering it on the computer. So in here, we also let the computer number the bonds. We are not interfering with them at all. And in here, you have the C element, right? We're just transferring what we have on paper to the CAMG program. And in here, we have a 1 on the side. And then we have this I element over here, and then we have the 0 on the right hand side, which goes to another one junction that has the R element, right? So we have it like this, and then we went to a one junction here. Of course, this we haven't reduced anything on this bond graph, which we could, but I think just so to illustrate the principle on how you do this, we're going to leave this for now this way. And then we have, is that right? Yeah, we still don't have that yet, but this is going to be like this. Okay, and then we have a one junction here, and then we have this also another element in there. Okay, and then what do we have? And then we have it like this, and then we have it like that. Okay, this is the bond graph model that I just that I have here on the left. See, see there, and then on the right hand side. But in doing this transfer, something occurred here, and it looks like we have a problem that I would like you to see what it is. And I'm glad it occurred because not all things go perfect, and this is a good example of this. Do you see here there is something funny about this? This is red. And why do you think this is red? The reason is that I have made a mistake right here. Do you see what I just did? Instead of a 1, I put an I in here. I need to use my glasses better, but you see here, this is not an I, it's a 1. And so when you put an I in here, the computer says, oh, wait, I think he means this is like a field, like I field with 3 bonds. And that's not what we're doing right now. So I think we're going to delete this. Okay, we're going to delete the other bond in here. And we're going to do a little surgery here to correct the mistake. See, this should be a 1, not an I. So if you put a 1 in here, right there, and we do this, let's see here, this is how we had it, like this, and then we had this, and then things are perfectly fine. You see this all white, not what is my output? That is the important thing, because we need to obtain now theta 2. In my case, theta 2 is or theta 2 becomes the velocity of the second one would be f sub 6, right? So let's just do that before we finish. And so we go to MATLAB, and I'm going to go to f sub 6, which is so the programs are going to be hold on a second. Okay, we go to the interface now. to MATLAB, and then we get the two programs talking to each other, and what is going to happen is CAMG will deliver these files to MATLAB, and particularly this file that's called CAMGSYM, which stands for the symbolic file. This is the one that we use for transfer functions. So in here, our objective is to get the number 6, I believe, is the bond that we have, is the theta 2 over here. We can extract this bond graph and put it into our nodes next to the one that we have, and we see exactly what we need for in terms of the output. So f sub 6 is going to be the output here, which corresponds to this. Theta 2, of course, would be the integral of f sub 6, but if we get f sub 6 is theta 2 dot, and that's going to be the output that we want. So in here, we need to come in here and look, find f6. This is f6, and when you go here, you activate these 3 lines, which basically allows you to define f6 as your number 1 output, and then you put this 1 in here for the 2 rows of the C and the D matrix. And there's only one more thing that we need to do on this version of MATLAB. There is one statement that it doesn't like, and that's this one. So we'll just comment that. When we run it, we will obtain the answer that we are looking for. So if you're running here, you say this is the input. We have 1 output, but we have 3 inputs. So input number 1 is SE1. So it gives us the A, B, C, and D matrices, and then the computer will give us the transfer function that we want. Okay, so this is the transfer function here. We have the this is 1 transfer function, 2, and 3. See, so this would be with respect to the first input, second, and third. So these are the transfer functions that we're looking for. So the transfer function would be the numerator divided by this denominator, right? I think that's how we find the transfer function in here. This would be the 1 over this for the first transfer function. Remember, is with respect to the input 1, 2, and 3. In our case, we want with respect to the first one, so that would be our first transfer function. Okay.